Thank you. Yes, I'm working at the Joint Research Center of the European Commission, which is located in northern Italy, at least the part where I work with. But the JRC is a much wider organization. It's located in 5 different places in Europe. It's quite a big organization. We are around 3,000 employees. Much of these 3,000 are researchers. In Jersey, we focus on a wide range of research topics supporting different EU policy goals. And this includes areas like climate change, energy, digital transformation, health, security, and so on, with, in general, strong emphasis on sustainable development and innovation. Recently in Jersey, we created, in recent years, an internal cloud platform, which is named BDAP, Big Data Analytic Platform. This platform serves the needs for storage, for processing capabilities, for data analytics activities of all the researchers. And this platform has many different services, among which we activated Jupyter Lab, and in particular the possibility to create Voilà dashboards to communicate the results of the scientific teams. So my presentation will dive into the activities that we recently did in Voilà, in creating dashboard to communicate scientific results. And I will talk first of all about this library, which is called the Voice Library. Voice stands for Voilà Simplification Library. It's a library that we created step by step by taking a piece of code that we developed to create some specific dashboard, and then we try to generalize. And recently we deployed it, we released it as an open source in the code.europa.eu, that is the official open source platform of it's a GitLab platform of the European Commission. If you search in GitHub, there is also a mirror under my name, Davide Marchi. There is a voice already, so you don't need to go to the code.europa.eu, but don't tell to the Commission. You have also the documentation here. You can install by using pip or CondaForge. The components of this library are basically to put together elements that can be useful in creating compelling data visualization dashboards. First of all, we started to use IPy widgets, but we found that they are too limiting. So we started to use IPy Beautify, which we think is a much more beautiful library for creating widgets. It allows to create composite widgets, so you can put together, I don't know, an icon inside a button, and inside, aside to the icon, you put a text or you put other things. So you can compose elements and making big and beautiful interface. We work a lot with geospatial content. So we started many years ago with Sylvain Corlet, the boss of QuantStack, that had a contract with us, developing some part of IPy Leaflet, and we continue to use it. We find it very useful. We use standard libraries for creating charts, like Plotly, which we love a lot. But sometimes we also use, we do the things in the hard way. So when we need to create specific charts, we use SVG and CSS, and also we capture events with IPy events. So we are able to create charts that are interactive, so that you can click on elements of the chart, get the coordinate of the chart or the click inside the Python kernel, and so react accordingly. So maybe call a Python function and so on. This is particularly useful when you have to create charts that are responsive, so that they behave according to the dimension of the screen, which is not so easy to do with Plotly. The objectives of the voice library are listed here. I will not go in detail, but there are some that are for us important. With voice, we can create full screen applications, so application that take the full Jupyter Lab screen. We can create compound elements by grouping widgets, putting together widgets in a hierarchy. And also we can create layered components, which we mean by this term pop-up menus, dialog boxes that pop up from the screen, and also multi-page applications. So applications that are composed of many different pages. And all of these elements give the possibility to create applications that are similar to desktop applications, so that are full of functionalities, that display complex data sets, that enable important, very specific interaction modes with the user. This is an example of the application that I'm talking about. This is a application developed together with Eurostat, working on a data set that is called LUCAS. LUCAS stands for Land Use, Land Cover, Area Frame Statistical Survey. The aim of this project is to collect data on land cover, land use, and environmental parameters across the European Union. And this data is crucial for informing policy decisions related to agriculture, environment, and so on. As you can see here, the application features a double map element where you can switch from a global view to a very detailed view. There are around 100,000 points spread all over Europe, and on each point there is a complex set of data. There are, for each point, 41 secondary points that where agronomists that went to the field collect information. In this particular case, information on landscape features that are all these elements that are aside the agricultural landscape that contribute to biodiversity. They can be grass, they can be trees, they can be little piece of water, and so on. So this application lets you interact with this complex data set made up of pictures, metadata, geospatial data. And here, in particular, you see a second page, a secondary page of the application that displays global information at the country and regional level. And here you can see in this exactly moment the possibility to create density maps on the fly, selecting the landscape feature you are interested in. So this is just an example, but it's the type of application that we are targeting with our library. Instead, inside the BDAP, the Big Data Analytic Platforms, we set up a service that we call VAS, Voilà as a Service. It's an automated pipeline for autonomous deploy of dashboard in production. So agronomists, geologists, any kind of researchers in our organization can create their own dashboards and deploy autonomously in production using our GitLab instance. This gave rise to a community of dashboard developers, and we try to follow them by providing training courses, workshop, demos, and the development of voice is useful for creating a common base of software that can be used by all of these colleagues. Of course, geospatial data visualization is a common feature, but since Voilà is not a point-and-click dashboarding tool, so it's not other types of dashboarding tool where you drag and drop elements on the page. Voilà needs you to develop, to write code. It's difficult for part-time developers to create beautiful dashboard because consider an agronomist or a geologist that do the development part as only a small part of their work. So what we try to do, we try to assist them in dealing with the steep learning curves of creating good dashboards. So for this, we came up with the concept of meta dashboards. So we developed dashboards that help in creating dashboards. So what are meta dashboards? Are web application where you have editing tools of the main component of the dashboard, or the framework of your dashboard, where you can create the initial structure of the dashboard in a visual way. What you get is an initial IPyMB file and the JSON file that contains the settings that you have created visually. Then you start the development of your dashboard. You can add other pages. You can add other functions. In particular, we are targeting dashboards that are multi-page. So we created a standard way of creating the front page of your application. And then on the front page, you have buttons to open other pages that do specific things. This is an example. It's the main meta dashboard that we created. It has two buttons on the page. The first one on the left that was clicked now enables you to create the main page. The main page is what you see is what you get editor. So you see on the right how your front page will appear. You can change the title, you can change the subtitle, as the video is doing now. You can set the logo, you can change the characteristic, the opacity, the font, etc. So you visually create your front page. And then if you go to the background, you can select among a list of 100 or something background images. You can, of course, upload your background images that you want. You can operate on opacity, on brightness, etc., so that the background is not so invadent. And then the most important part, you can add buttons. So you can add a button called function 1. You set the title, the subtitle, and the name of the Python function that will be called when you click on the button. So in this, the video is doing a second function, function 2 with F2 as the name of the Python function. You can work on the buttons so that they are more opaque, more transparent, bigger, thicker, etc. At the end, when you are fine with it, you can change other things. The credits on the bottom of the page. You can remove the voice logo on the top of the page, etc. When you're fine with your page, you just click on the. Okay, I removed it. Click on the download. You give a name. The application, the meta dashboard, downloads for you an IPyMB and the JSON file, and then what you can do, you have these two files. You drag and drop on your Jupyter Lab, and you can examine what the code is, how the code is produced. Of course, you see the two functions F1 and F2 that we have asked for the creation. The two functions for the moment just display a dialog box. In the last part of the screen, you see the loading of the JSON file. The JSON file, so now we can execute the cell here, and you have exactly at full screen the application that you have. So, and clicking on the function 1 and function 2 buttons, you have the dialog message. So very, very easy. Just examine briefly the JSON. It has all the information that we have inserted, in particular the two buttons, F1 and F2, where you can manually edit, the subtitle or the tooltip or whatever, or you can add an image, for instance. Of course, there is also the possibility to reload these two files in the meta dashboard application and continue to change, to edit something graphically and not only. So you can do it manually or graphically. Going a step further, you have also a page configurator, so an analogous system that enables you to create a typical geospatial page. So you can also, in this case, you have what you see is what you get. So you see the geospatial part on the main part of the window. You can set the title and the subtitle. You can, we use the color theory to help user to create primary and secondary color that are consistent. So you can, for instance, just select a single important color for you, and the secondary color is selected automatically. So as you change the color, the application changes completely. You can define to have one only panel for buttons, or have another or other two foldable panel for putting your widgets. So at the end, you can go to the content of the page, and on the main content of the page, you can decide to have one part, or two or three, or put it in vertical, in horizontal form. In this case, the example creates a content with 3 elements. On the upper left part, there is a map. On the left bottom, a Plotly chart. And on the greatest part, another map. You can select the characteristic of the map so that user can change or not change the background, can view the coordinates or not, can manage the clicks or not. The two maps can be linked together, so that when you do zoom and panning, the other maps behave accordingly. And as before, you do the download, and what you have are, in this case, 3 different files. The files are a PyMB, a .py, and a JSON. So as before, you can drag and drop on your Jupyter Lab. You can examine what is inside. Of course, all the settings that you have done visually, you will find in the JSON. In particular, we are seeing part of the JSON. The code, in this case, it is a Python class where the framework of your page is already created. You have just to intervene in some points to, for instance, change what happens when you click the help button, or you click on the logo, or you click on the credits image, and so on. In this case, also few example widgets are created, like a switch and the button. And when you execute this code, you have exactly the page that you have created graphically. So here is the page with some example widgets on the left. So without writing a single line of code, you have the framework of your application. Of course, these two parts, the main page and the content page, the geographical page, can be linked together, so that from the main page in the button F1 or F2, you launch this this secondary page. And then, of course, the most complex part comes. Then you can add widgets on your page, you can add behavior, you add your code, and so on. Using this method, we have around 10 to 15 colleagues that are developing dashboards in the different fields, like in agriculture, in social science, in biology, and so on. Here I will just show you as examples 3. If I have how much time I have? Okay, so we skip the first one. I will show to you two real dashboards. I will skip this one. Both are in the field of air quality monitoring. The one is called Sherpa, and it's an application that is substituting a desktop application that was distributed since 2 years ago to a community of around 700, 800 researchers working on modeling of air quality in Europe. This application, distributed as a desktop, occupied around 1 gigabyte. So every time there was a bug, there was the need to send 1 gigabyte of executable to all these members. What this application does, it enables you to select, just stop a second, to select a location in Europe, like a region or 2 regions or many regions or sub-regions, etc., and simulate the policy of reduction of pollution what is the consequence on the concentration of pollutants itself. So there is a part of calculation, but in this case, the video shows you a calculation that is already stored. So it's loading a previously calculated simulation. The result of the simulation is a raster file showing the areas where the concentration decreases more, in this case, where the concentration is higher. This is PM 2.5. And the most polluted area in Europe is the Pianura Padana in the northern part of Italy. And also it does a simulation of the effects on human health, like the number of people, the decreasing in number of people having asthma or other respiratory problems. Of course, you can, on the fly, aggregate data at regional and national level. And what is important, you can do a cost-benefit analysis using a dialog box that pop up from the screen, seeing the splitting of cost on the different countries and the comparison of the cost with the monetarized benefits obtained from less deaths, less health problems, and so on. So it's a complex application. The second one is in the same field, is called Fair Mode, and it is dedicated to a community of air quality modelers, and the objective is to evaluate the fit for purpose of their model. So universities, research center working in this field create models that try to model the air quality concentration in all the continent. These models are raster files generally. So here the application shows you how to select one of the model files, in particular one on the Pianura Padana, and the application compares the model, the predicted model's values, the raster, with the data measured in acquisition stations. So it's a comparison of observed and modeled value. The graph that you see on the left part, the ideal situation is that all the points are on the bisector of the first quarter, so that the model perfectly fits the observation, but of course this does not happen in reality. From a technical point of view, this chart is a SVG chart, so it's created specifically for this application, and it works in collaboration with the map. So every time you zoom on the map, you have a consequence in the chart, and the opposite. So you can click on the chart and see the points where it is on the map, and so on. Of course, you can compare also different models. In this case, you select an area you are interested in, and you see a synthetic result, this MQI, which is good. It's a synthetic value that if it is less than 1 means that the models behave in a very good way compared to the observation. And you can load, once you set a focus area, you can load other models to see how the other models behave in the same station. So here we are loading an Italian model and a European model, and they behave badly than a local model, which is quite obvious. Other examples, other functions of the same dashboard are the possibility to see a global view of which are the best models according to this synthetic measure on all the NUTS2, so the region areas in Europe, and create what they call a Frankenstein map. So a map created on the fly that puts together all the best models for each of the different areas of Europe, what you see on the right. So just to conclude, I think that with these applications that we developed, we took Voilà dashboard to a great level. So we demonstrated that Voilà can be very useful in creating real-world web applications, so not only demos or communication of scientific results. The voice library that we developed is heavily used in the European Commission, and we hope that is also adopted elsewhere. And this trick of the meta dashboards for us works very well because it enables non-professional developers to start having a good framework for their dashboard projects. Thank you so much.
Perfect. Thank you, Davide. So we have questions. Oh, sorry. I couldn't see you.
Thanks a lot for the great talk. It's very impressive. I have 3 questions. Is everything open source here? The builder, dashboard builder, and all the...
Yes, in the what I show you, I cannot see. Okay. okay, I see you. Yes, it is all open source. The voice, you have the link to the GitLab of code.europa.eu, and the meta dashboard is inside the package templates that is inside the library. Unfortunately, in the abstract, I wrote a URL that is no more active. So voice.azurewebsite.net, we did a proof of concept in Azure, but they closed it the 1st of September, just after I published it. But now we will continue with another, we will open a new subscription. But in any case, downloading the voice library, you have the possibility to have this meta dashboard already configured.
Okay. And so second question is about authentication. Do you have some modules or thing already done about that?
This is a tough issue. At the Commission, we are required to use what is called EU login.
Okay.
It's a European level authentication and authorization system. Not so easy to use, but yeah, we are stick to use it.
Okay. And the third question is about the hosting constraints. Is there some... Can you host the final dashboard on a custom server, on-premise server?
Yes, in theory, yes, you can do wherever you want. The crucial point here is what we call the dynamic tile server. So how to serve the geospatial content. Here, in all these examples, you have not big data. You have quite small data. But when you have a raster of 1 terabyte, you have to serve it in a complex way. So inside our cloud, we have a dynamic tile server. There are others. I saw yesterday the presentation from Jupyter GIS. They integrated inside the TI tiler, which is does exactly the same. So there are many possibilities open source. We are using only for this part an internal product that is developed in C++. So it's not open source, but you can use other dynamic tile server. Yeah, and the deployment can be done. We have done experiments in OVH, in Azure, in AWS. So you can do almost everything.
Thank you. Any other question? Yep. And then it will be the last one. I'm sorry.
Yeah. Thank you for the great talk. So I have a question about the performance of the dashboard. So what happens when the data is so big? Is it optimized for that kind of operations, or?
Yeah, when you work with geospatial data that is really big, you have a trick that works very well. That is the pyramid layers. So when you have raster, you create a version of the same raster that are of reduced resolution. So you do a 2 by 2. Every 2 by 2 pixel, you save just one, and then you do it again and again and again. So you have a pyramid where the original raster is visible only when you access a very small part. When you see all Europe, you will see a very reduced resolution that is already prepared. So this is a standard way to work with a very huge data set. Of course, with vector data, the problem is complex. We use a server-side rasterizer of vector data. So the points of the station that you have seen are not passed to the client. They are rendered in raster by the server using Mapnik, which gives to you the possibility to have quite huge data sets, but it has other consequences. So, but there are methods to tackle big data sets.
Okay, so let's thanks again, Davide.